In this example, we're going to again use the elimination method theorem to solve this system of two linear differential equations. X double prime plus y prime minus y is 4. That's equation number 1. 4x plus y prime minus y is equal to 8. That's equation number 2. So one thing, if I were to ask you right now, how many constants are we allowed to have, or parameters, in the solution? Well, you should be saying 3, because this is a second order differential equation and this one is a first order. So we're allowed to have like a C1, C2, C3, for example. Okay, in rewriting this, using the differential operator, we get this right here. I call them 1 and 2 again, only because these two are exactly equivalent to those two. And by the elimination method theorem, I chose to start with y this time, although it doesn't matter. We take the d squared, the coefficients of the x's and y's, d squared, d minus 1, 4, and d minus 1. That becomes a matrix that we take the determinant of and apply it to y. And then the right-hand side is the determinant of this, which is, for y, we replace the second column with f1 of t and f2 of t. So this column matches this one. And remember, if this were x, this column would match that column. Okay, so what do we have here? The determinant of this is d squared times d minus 1 minus 4 times d minus 1. So I'm going to save a little bit of room. And d squared times d minus 1 is d cubed minus d squared minus 4d minus 1. So that would be 4d minus 1 in parentheses would be 4d minus 4d plus 1. So double check that this is the determinant of, well, this determinant is equal to this. Okay, so this applied to y is equal to the determinant of this. Okay, that's going to be d squared applied to 8 minus 16. 8's a constant. What's the derivative of a constant? 0. So the second derivative of a constant is certainly 0. I'm just going to put an x through there and make a note that it's 0. So this is equal to negative 16. And using the characteristic equation for this, I would get m cubed minus m squared minus 4m plus 1 is equal to negative 16. Let me do that correctly. We're doing just the homogeneous case, so that's a 0. We'll worry about the negative 16 when we figure out a particular solution. So to get the homogeneous, I'll write it in really small here. Homogeneous, we solve this characteristic equation. And it's very easy to factor this. It'll factor by grouping. What am I missing? This is what did I get wrong? This was a 4 and this is a 4. So I did the d squared times d minus 1 minus, this was 4d minus 4, but there was a minus sign in front of it, so it becomes minus 4d plus 4. Okay, this is easy to factor. Factor by grouping, you'd have m squared times m minus 1 minus 4 times m minus 1. And that would give us a m equal negative 2, 1, and 2. So based upon that, again, I skipped a little bit of factoring and algebra there. We know that y is equal to, I could say y of t, c1 e to the negative 2t plus c2 e to the t plus c3 e to the 2t. And again, since it's 3 distinct roots, we simply put a ci e to the t, and the coefficient of the t, and the first one is this one, and the next one is this one, and the next one is this one. I'll go ahead and put a box around it. And I think what I'm going to do is, let's go ahead and completely solve this. So using the method of undetermined coefficients to get a particular solution, all of this equal to negative 16 means we would just say, guess that a particular solution is capital A, since it's a constant. Well, notice, let's see, this is the same as y triple prime minus y double prime minus 4y prime plus 4y equals negative 16. I'm doing that because I'm going to cheat and not write down every single step. If my particular solution is A, what's the derivative of A? It's a constant, so it will be 0. Second derivative, 0. Third derivative, 0. So if I'm guessing that yp is an A, all these are zeros, and I get 4a equals negative 16, and a is equal to negative 4. So my A, let's see, let me put it down here. This is the homogeneous, so I'm going to put YH there. Y is equal to that plus negative 4. C1 e to the negative 2t plus C2 e to the t plus C3 e to the 2t minus 4. Put a box around that. That is what y is equal to. And let me just say that when we do the equation for x, it's going to be identical to this, only instead of a negative 16, we get something different. But the homogeneous portion is going to be exactly the same. I'm going to leave that for you. Similarly, we get, using the other equation from the theorem, we get x is equal to C1. It's almost identical. Oh, I can't reuse C1, C2, or C3. C4 e to the negative 2t plus C5 e to the t plus C6 e to the 2t plus 1. So the only thing different between x and y is the portion we determine, the particular solution that we determine using a method of undetermined coefficients. So we've got this, which I'm going to leave you that work if you want to go ahead and work through it. It'll look almost identical to this. Now we just have one problem. This would be our final answer, this and this, except that we've got 1, 2, 3, 4, 5. We've got 6 constants, and we're only allowed to have 3. Okay, so what we're going to do is take equation number 2. I've started it already here. Here's what we have. Here is the x that we just solved. Here's the y that we just solved, although technically I didn't solve x. So by equation number 2 that we have up here, this right here implies, now notice what I did. I wrote it one above the other. I made a column with 4x and then y prime and then minus y. Because I'm going to write out what 4x is right here. 4x would be 4c4 e to the negative 2t plus 4c5 e to the t plus 4c6 e to the 2t plus 4. Almost ran out of room on that one. And then y prime, oh, I didn't work that out yet. Y prime, if this is y prime is going to be negative 2c1 e to the negative 2t plus c2 e to the t plus 2c3 e to the 2t plus 0. Because the derivative of negative 4 is 0. Now minus y. So I'm just going to take y and multiply, or change all of these signs. Multiplying by negative 1 just makes all the positives negatives, and the negative 4 will become a positive 4. So negative c1 e to the negative 2t minus c2e to the t minus c3 e to the 2t plus 4. And when you add up all these three, I'm going to put a little squiggly between here. So this represents 4x, this represents y prime, this line represents negative y. When you add them together, you get 8. And it's easy to see when you add the constants together, there are only two constants, 4 and 4, and that gives us 8. So guess what that means? Everything else adds up to 0. So when we take the terms, let's see what we've got. Let's look at all of the e to the negative 2t's, just this column right here. Let me change colors. I'm going to have to write a little bit smaller. This tells us that these coefficients, these three coefficients, add up to 0. These coefficients add up to 0. These coefficients add up to 0. So that would give us that 4c4 minus, let's see, minus 2c1 minus 3c1 equals 0. This column here has to add up to 0. These are all the like terms. Notice the c2 and the c2 and the negative c2 cancel out. So I get 4 times c5 is equal to 0. Well, that's easy. I'm going to go ahead and say implies c5 equals 0. And then the third column we get how many? Oh, rats. Let's see, are we doing okay? Yeah, we are. We're good. On the last one, we've got C3s and C6s. So 4C6. And how many C3s do we have? 2 minus 1. Plus, so we plus 1 C3. Plus C3 is equal to 0. And I'm going to cheat and just say that that implies that, well, it's easy to tell here what C4 is. C4, if we added 3C1, then divided by C4, divided by the number 4, we'd get 3/4 C1. C5 equals 0. We knew that one. And then this one says that, let's see, C6 would be negative C3. Negative C3 divided by 4, which is C6 equals 1/4 C3. Now, why is that a positive? That needs to be a negative because we're subtracting and then dividing. Yeah. Okay, so that tells us what x of t is equal to. X of t is equal to C4 is just 3/4 of C1. e to the negative 2t. All right, the next term, c5 e to the t, well, that's a 0. So that term goes away. And then c6 is negative 1/4 c3 e to the 2t plus 1. So I'm going to put a box around it, put a star by it, and then this y, put a box around it as well, a red box. That's the solution. Since we started with y, we gave it the c1, c2, c3, and then x ended up having a c4, c5, and c6, but we were able to, using this equation number 2, figure out how to write c4, 5, and 6 in terms of c1, 2, and 3. And it turns out that c2 is a 0. Which means that if C2, if C2 were a 0, we can actually cross this out. Oh, no. Forget what I just said. C5 is the 0. So just to finish this up, that star equation and this star equation, that's the solution.